All right, welcome to class today. Glad to see you all here. So, a little bit of logistics bits and things. We are on our last day of regular expressions. We'll talk about replacing and a few other odds and ends about them. If my morning class is any indication, we may end a few minutes early, maybe take some random questions. We shall see how that goes. I should also comment, you'll notice next week we just have varies by section on the schedule. As Professor Dill and I were talking about how we wanted that last week to go, we both agreed that what we did last semester probably not perfect. So we were just going to try something different than the other. So we will have different topics. Potentially I'll even have different topics in 10 a.m. than 2 p.m. We'll see if I'm that energetic. What this means for the exam is not yet determined. We have talked about having a pick one of several questions, so each of you can be tested on what you talk about. We've talked about just not testing it. We're not sure. And unclear when we will become sure. Probably not until after we finish teaching and decide if it went well. So, sorry I can't tell you in advance what that will be. But I can say that we are not having assignments about that material. So there'll be additional things we think you'll find useful and interesting related to the course in some way. Likely on the 1st of December, we will have an Ask Me Anything session where you will ask me anything and I will try to answer it, unless it's about the exam, in which case I'll say wait until Monday. To sort of answer any remaining questions you wished you knew about computers or the like. So we'll probably do that on the 1st if I can get everything else working out right. Yeah. I think that is, that's the bulk of what I wanted to say as far as logistics go. Any thoughts, comments, questions for me about logistics or anything else? Okay. Let me review where we ended up last time. So we had talked about how regular expressions work, how groups work, and then we had spent most of last class building some regular expressions. So the first one we did was this Python-style string, right? Quote some things that aren't quotes unless they have backslashes in front of them. And we built various different regular expressions that could do it, but the one we ended up with here, okay, was we said it should be a quote, and then any number of anything that is neither a quote nor a backslash, followed by any number of backslash anythings and anything that is neither a quote nor a backslash. So we have this technique for describing how strings work, and we match different strings with it in the Python sense. A little different than your quoted strings for homework. We also had finding addition problems. So we said we wanted one or more numbers separated by either plus or minus, maybe spaces. And so we had written this that said I want some number of digits, at least one, and then this parenthesized thing will happen any number of times, so any number of, and the thing we have any number of is any number of spaces, either a plus or a minus, any number of spaces, and another number. And that describes number, and then any number of operator number pairs to give us some addition problems. And so we talked about how that worked. And at the end we talked about grabbing some text from Lou's list and finding something that seemed to surround what we cared about, replacing the part we really cared about with a matching group, and using this to extract from the actual HTML the instructors of courses. So that's what we did last time. Any of these you'd like me to talk more about? Anything you're a little uncomfortable, just would like me to repeat because, you know, you like me repeating? Anything I should say? Okay, then we will move from here to talk about some other ideas. So, as we think about our regular expressions, so far we found how we can find generic strings with some amount of flexibility in other strings. And we can extract them and print out their parts. And that's often useful, but sometimes what we want to do is change them where they lay. So, let me come in here and make a new Python file that's going to use the ability to modify a string. Now, we can never actually modify strings in Python. Strings are immutable data types, which means that functions that change them don't change them, they make a copy that's different. But let's suppose I want to normalize names in English we have a couple of different ways we write names, right? Sometimes I write my name as Tychonovich, comma Luther, and sometimes I write it as Luther Tychonovich. Which technique we use, whether it's last name comma first or first last, depends on the setting in which it appears. So we typically use last comma first if we're sorting something alphabetically, or if we're sort of storing it in a data-like context. And we tend to write first last with a space if we're writing in a more colloquial prose kind of context, in the middle of some other text. But in general, both might exist. And if I have someplace I'm asking people to type their name, I might expect them to type it either way, depending on how they're expecting it should work. So one of the things I'd like to be able to do is to take this example and change it around to normalize how it appears, so that all instances of a name appear in the same format. So to do this, I first want to make myself a regular expression that will help me understand, to help me match one of the two types of names. And I'll try to change that name into the other type. So let's try to match the type with a comma first. I'm going to assume an oversimplified version of names that begin with a capital letter, have 0 or more lowercase letters after them. Okay? Clearly there are names that do not meet this simple criteria, but it's a reasonable baseline. Okay? So I'm going to start with names that have a capital any number of lowercase, then I need a comma space, and then I need another one of those things. And this will match one of my two types of names, assuming that there's no non-letter characters or changed places of the capitals or so on. There are people in this class that this will not work for. But for many of us, this will work, right? It'll allow us to match a last name and a first name. It won't allow us to match multiple names and so on. We could try to fix that if we wanted. But this is a baseline of how we might find a name. Finding the names that I want to change is part of the job. The other part is finding the pieces of it that I will need to do the changing. So I want to put some capturing groups around the portions that I want to capture. The last name and the first name. I don't really care about the comma space, so I'll leave them outside of a parenthesis. I'll just put a parenthesis around the two names I wanted. Although if I had extra parentheses, it wouldn't matter. I just need to grab the correct pair of matches. And so I can build this regular expression to match a capitalized last name, capitalized first name with a comma in between, or anything else that looks like that. Thoughts, comments, questions? Okay. This is as far as Pythex can take me. From here, we're going to need to switch over to Python, because what we want to do with one of these things once we find them is change the original. We're going to modify the original string, or really create a copy that's different, that has that thing changed. So let's make our name, will be a re.compile, we'll make a raw string here, and paste what we had there. And just to make sure that it works as here as well, let's just test it out, make sure we get the ones we want. Oh, right. Don't print name, print m. Not m, print m.group. Sorry. Alright, so m.group gives me a whole string. It shows me that it found that version of my name but not the other. I could also make sure that I have the bits and pieces I want by asking for the groups. And you'll see the groups that I have matched are my two names. So that looks promising. Okay? Sorry, this cord just cut on something. Alright. So I have the information, and I could use this information to create the name I want. Right? I could say that the fixed name is going to be, let's see, I want the second group first, because that's the one that's my first name, then a space, and then I want the first group with proper spacing. And if I print out fix, I will see that it prints it out in the way I want it to be. Right? I've changed it from having one format to the other. But I have not put it back into the original string. Sometimes this is all you need. Sometimes I change it, I make the changed one, and I move on. But sometimes I want to normalize the original string, so I still just have one big string, but with things presented the way I expect them to be presented. So I might want to replace some portion of the original string using a regular expression to modify what goes on as I do that. All right, so let's talk about how we do that. We have seen how to replace things before. We have seen, for example, if I type hi dot replace the H with a W, then I'm going to get we. Okay? This type of replace we've seen since fairly early in the semester, a method of strings, that if you tell a string to replace one thing with another, it replaces that thing with the other thing. As we think about this, we have first the the original goes first, then the thing to find, and then the replacement. Regular expressions aren't going to use this order. And they aren't going to use this order in part because they can't. Let me explain what I mean by that. If we think about our various regular expressions, regular expression functions, we have search that we've talked about. Okay? Search will ask for the text in the parentheses because it's the regular expression, the compiled regular expression that does the searching. So I have to say r.search rather than text.search because the regular expression is the thing that knows how to search. And the thing that's doing the work appears on the left side of the period. I similarly have findItter that also has that same characteristic. And findAll as well, although we use that much less often. Okay? So we have these methods of regular expressions. And our replacement is going to have this same basic structure. So our replacement is going to have a regular expression, dot, and because it is different order, they've named it sub instead of replace. But if we think about the role that R serves here, this is the thing to find. This thing that describes what we're looking for. So we already have things out of order from the original. Okay? I'm finding first, and then I need to decide where does the thing I'm replacing it with go, and where does the text go. I've got two things, they need to be in some order, and we could have picked either one. There's no obvious reason why either order is better than the others. The decision that the regular expression people made was to just slide everything down. So I still have the find thing, I have the thing I replace it with, and then I have the original text. Okay? Is the order they expect things to come in. Now, you don't need to memorize this because Python knows it. So if I come in here and I say, name, I want you to substitute something, right here, PyCharm tells me the order in which it expects information. It expects itself first, that was off to the left of sub, then the replacement, then the string. And optionally you can also have a count for how many of them you want to have replaced. We'll ignore the count for today. So I know that I need to have the thing I'm replacing them with, let's just replace them with next for now, and then the original string. So this should just replace the first copy of my name with the text next. And if I print this out afterwards, I will see that it fails to do its job. It fails to do its job, it prints out the original string unmodified because you can't modify a string. Functions, methods, it doesn't matter, you can't change a string. Everything that looks like it's changing a string is really giving you a new string. But if I print out that new string, I will see it has nixed my first name. The first copy of my name, I should say. Okay? It has found that thing that matched and replaced it with the thing I asked it to replace it with. And it will do this in general, right? If I add in some other names here, of, say, the other instructor this semester of this course, I can see any of those that have that last name, comma, first name model get replaced, and the others don't. But the replacement gets saved in a new variable, and so I have to print out that new variable in order to see it. Thoughts, comments, questions so far? Okay, this only gets me so far. I can replace the names that are in the wrong format, but so far we haven't seen how to replace them with something based on what they looked like before. To understand that, let's go briefly look at the Python documentation. So let me go search for, go open up a search engine, and here I am going to ask for Python 3 regular expression. And great, this looks fine. I'll go into the Python 3 regular expression, and it provides some documentation about regular expressions. It provides, saying some is a little bit misleading. It provides a lot of documentation about regular expressions, including, down at the end, entire programs that use regular expressions to do moderately interesting things. Okay? There's a lot that they say about regular expressions because they're a powerful tool. But if we look through this, one of the things we want to know is how do we substitute? And I can see here we have this description of sub. Okay? And if I look at sub, it has this conversation, this description of what sub does. There's a few things to observe here. There's multiple versions of sub in regular expression library. The one we've been using works with a compiled regular expression first, and is generally preferable, but most of the descriptions assume you use the other one where you put the regular expression string as one of the many arguments of your sub expression. So this has the regular expression here, and then the thing that we're replacing it with, and then the source, and so on. So we have this different order of the information. But as we're going along, there is some information they provide us. Let me zoom in a bit so we can see that more easily. All right. If we just look at this very first paragraph, it talks about how we can have backslashes inside the substitution text. So we have \n, it turns into a new line, r turns into carriage return, etc. J doesn't turn into anything because we don't know what it means. And then it has this extra statement, back references such as /6 are replaced by the substring matched by group 6 in the pattern. So we can put \digit in the replacement text in order to grab those groups in the original text. So if I go in here and instead of replacing this with next, I say I want group 2 space group 1, because group 2 is my first name, group 1 is my last name. Because I want backslashes in here, I'll make this an R string, so that I keep the backslashes in their natural form. And now it is going to replace Dill Craig with Craig Dill, and Tykonovich Luther with Luther Tykonovich. It's changing the order. I can mix this up however I want. I could, for example, say the original was 1, 2. I could even decide that I just really, really, really like seeing somebody's first name. It's fine with that. It doesn't care. You can do whatever you want with the groups. Make any string that contains these groups \digit, and it'll grab that appropriate group out of the thing and use it as part of what gets replaced. Thoughts, comments, questions? Yeah?
How do you put R every time you do a
Good question. So we talked about this, 2 classes ago? But let's hit it again. An R string, called a raw string, is designed to make backslashes not special. Since backslashes are commonly used inside of regular expressions, but they also have a special meaning creating escape sequences in strings. Usually I don't want my backslashes to mean the next thing is special in a string sense. I want it to mean they're special in a regular expression sense. So for example, if I wanted to have a backslash followed by anything, the regular expression needs to be a backslash backslash, so I know the backslash is not a regular expression special backslash, and then anything is a period. But since strings have backslashes special, if I didn't have an R string, I need that to be a backslash backslash to be the first backslash, and then a backslash backslash to be the second backslash, and then the period, which quickly looks ugly. So we usually use R strings to say that backslashes are not to be interpreted as string escapes. Does this answer your question? Okay. Other questions? Yes? The order of parameters to sub.
Oh yeah, but it has to be memorized.
If we need you to know the order, we'll remind you on it. Yeah, not worth wasting brain cells on. Yes?
How would you call the function the way that it was used in the Python?
Yeah, so it turns out all of the regular expression methods we've talked about, all of them can be used without compiling first. And the way that looks is I say re.sub instead of name.sub. But then since I don't know what regular expression it is, the first thing I put in here is the regular expression. And then I put everything I would normally put in. And that will do the same thing. It will run slower. But that isn't the reason I don't usually talk about it. I usually talk about it because the more arguments you have to remember the right order of, the more confusing things get, in my opinion. And saying the regular expression does the substituting, I find personally to be easier to remember than this order of arguments. Yes?
So it's better to do the first way and figure it out this way?
Yeah, I would encourage you not to do this way, although knowing that it exists will help if you want to read the documentation. The reason the documentation likes it is because it shows the regular expression and everything else all in one line, which makes the documentation shorter. So I understand why they chose what they did, but anyway. Other thoughts, comments, questions? Okay. There are some perhaps obvious, perhaps surprising. I guess it depends on what you find surprising. In my experience, some people find some of the things I'm about to say surprising and some don't. But there are some oddities about how substituting works. So let's make a new regular expression, which I'm going to compile. And it's going to be one of the simplest regular expressions I can make. It has no special characters at all. It just matches the string Anna. Okay? And then I'm going to make banana, which is going to be the text banana. Okay? And now let's say fixed is going to be Anna.substitute with nothing in banana. Print out the fixed. This will print something. Chat with your neighbor, see if you can decide what it will print. And the answer is Let's explore briefly why this happens. I'm going to take this text and go over to Pythex. Okay, let's use this as our example text. Our regular expression was Anna. Notice what it highlights. Anna, Anna, Anna. It does not, importantly, does not highlight this Anna that I have now highlighted on top of it. The rule with regular expressions that applies to all of these functions we've talked about is we start looking for the second match after the end of the first. So they will never overlap. Okay, so we will only look for the second one after the end of the first. And so we will never find the blue highlighted Anna because the first green highlighted Anna already used that A. And so we start looking for the second Anna after the N. Okay, which is why we find 3 of them rather than 2. Or rather than 5, I should say. If I get rid of the last N, I will see there's a spare at the end. Because, again, I don't have any Anna for that last A to go with. We start at the left, not at the right when we're looking. So we find this Anna and that Anna rather than this Anna and that Anna. Start at the left, find the first one we can, make it as long as the regular expression allows, and then at the end of that, start looking for the next. Questions about this? All right, let's change this a little bit. What if I substitute it with an A? Again, chat with your neighbors, decide what you think it will do, and then we'll talk about it. And I run it, I get banana. Whoa, why did I get banana? There's Annas in banana and it didn't remove them. Why not? Okay, and again, this happens because the sub follows the same rules as everything else. It removes the first one it finds and looks after that for the next one. So this Anna turns into the first A. And then this Anna turns into the second A. And then this Anna turns into the third A. To turn banana into banana. Okay, so this may or may not be important. I bring it up here because you may occasionally be surprised what happens. Question?
Is there a way to make it so it doesn't do that and overlaps?
There is no way of asking a single invocation of regular expression methods to have overlapping matches. I could change my regular expression to be bigger, right? I could say, you know what, I want to match and then at least one nuz. And then we'll just match the whole thing and turn it all into one A poof. Okay, but as long as I say one Anna is what you match, then you replace one Anna at a time without overlap. If I really want to sort of keep going until things stabilize, then I could just rerun it on the result of the first invocation and turn banana into bana. And I could do that again to turn banana into ba. Okay, so I can keep running it on itself over and over again. If you think about this though, what's going on is each time I'm taking this thing that had 2 A's and turning it into 1 A. So each of these invocations is at most going to cut the number of A's in half. So if I start out with a biggish number and I want to get down to a smallish number, I'm going to have to cut it in half several times. In particular, the log base 2 of the number of times it originally appeared, but that's a complete side note. Other questions? Okay, so this is sub. Sub is often useful. None of the assignments we've given you force you to use sub. But some of them you'll find easier, perhaps, if you do use them. The main purpose of sub is typically to normalize information. It might come in any of several formats. We turn it all into one format, and then we can write simpler code to deal with that one format. Let's see an example of where this might come in handy. If we go to the assignment that is due next week, one of the first things we do is we ask you to normalize a name. So in any of these format it comes in, we want it in that format when you're done. There are lots of ways of doing this. You absolutely don't have to use sub of regular expressions to make this work. But I think you may find that using sub will simplify your life. Will make it easier to do what you want to do than not using it. So I'd encourage you to think about it as you're going in that, or if you find it confusing, go ahead and do it another way. But this is the sort of thing that regular expression sub is particularly good at. Okay. So that's sub. There are actually a lot of other things that regular expressions can do, as witnessed by the fact that we have lots and lots of things going on here. There are expand, oh, that's about groups. We have, in addition to search, there's something called match, which does the same thing as search, but it has to match at the beginning of the string. It doesn't allow it to start partway through. There's also full match, which will require you, where is full match here? Oh, maybe it's up in the other one. Anyway, there's also a full match that require you to match everything, not just the beginning. There's a split and a find all, find iter. We've talked about sub. We've talked about there's another kind of sub that does something slightly different. Okay, there's various kinds of things we can do to deal with what's going on. But I want to talk a little bit here about split next. Split might become useful for various things you'll do, and we're going to use it as a simple example that we didn't do last time. So as we were doing our practice, at the end I asked you, did you want to see the web or see how to perform addition? And you said the web. Great. Now we'll talk about how to perform addition. So let me just grab this exact comment we had here, and we're going to just pop this out into a new Python file, which I'm going to call regular expression split. So I'm going to import regular expression and paste what we had last time. So we were trying to find addition problems by looking for these numbers followed by some sequence of operator number. And when we ran this, we saw that it found the different examples that were there. So it can find the portions of a line that look like addition problems and not the portions that don't. That's great, but now what we want to do is evaluate what they mean. So we're going to look inside of one of these for the individual pieces, the numbers and the operators, inside one of these matches. We want all of them so that we can break it apart into its numbers and operator parts and use that to do the math. So let me say that my problem here is that group. I have found the problem I want to work on. But inside of that problem consists of numbers and operators. So let me make myself something that can find, let's say, just an operator. And we can say an operator is just a sub-part of what I had before. Okay? It is going to be just that middle piece. So I just grab that central piece that's separating out elements in what I have, and I can use that to split. Just like with the sub that we just talked about, the order will be a little bit different because the operator needs to do the splitting. And so it needs to split the prob, and because this can't change, I can have the parts is going to be coming out of that. And then let's print out those parts. And I see this list here. I see it has a list of a number, and an operator, and a number, and an operator, and a number, and an operator. No spaces in a list. And partly this is happening because of the way we wrote a regular expression. So we'll come back to this version in a moment. But let me change this from a group with alternation to a character class, since that's just a single character in the middle. If I do this, those operators just vanish. And we'll talk about why here in a moment. Okay? So I say the thing I want to split on is a space or more, or 0, an operator and a space or more, or 0. Then it is going to do the same thing that split does with string. It's going to find all of those things and remove it, and give me the list of things that were between them in the original string. So because I have removed the plus between 34 and 5. I see 34 and 5. And it's split on those operators in between. However, the split in regular expressions has this special behavior if there are groups, as most things with regular expressions do. If I put a group in here, the contents of that group will be inserted between the elements in the list. And so those operators that I have the parentheses around are now included in my list. And it's whatever I put in the parentheses. So if I include the spaces at the end will still be in there, but the spaces at the beginning won't. So wherever I choose to put the parentheses will dictate how much stuff gets put inside. So I can split while remembering some information about the thing I used to do the split. Thus breaking up my line into numbers and operators, but keeping both the numbers and the operators, something I can't easily do with a string split, which always removes the thing we're splitting on. Okay, questions so far? Yes?
You had two groups, what is?
It will put each of them in there.
Between each other.
Yep. So we'll put all of the capturing groups will go, you'll have a thing, all of the capturing groups, a thing, all of the capturing groups, in the same order, even if they're empty. Other questions? Okay. So I can use this to split things out, find my numbers and my operators in a list. As I look at this list, there's an important thing that's going to make my job easier. They always start with numbers. So the first thing is always a number. This will give me a place to start in my math. And the thing at odd indices are always operators. So at index 1 and 3 and 5 and 7 and 9, I have operators. At indexes 0 and 2 and 4 and 6 and 8 and 10, I have numbers. And so if I walk through this list every other index, I can make sure I find operators or numbers in the order I want. So this is the idea of what we're going to do. We're going to grab that first number and use that as the base. Then we're going to look for all of those operators by looking at every other spot and find the number that was right after them to do our math with. So let's walk through how that works. I'm going to say initially part 0 is my answer. And at some point, I'm going to print out the answer. So I grab part 0, I say that's the answer. Let's just go ahead and make sure that works. And I can see here that it's just showing me the first number is the answer. So far, so good. Now I want to loop over all of the operators by index so I can know the thing that's after them. Since I want to loop by index, I'm going to use a for I in range. I want to start at the first operator, which is at index 1. I want all of them, so we'll go up to the length of the parts, but I only want every other index. So we have mentioned briefly you can do this with ranges. This is one of the cases where it actually is the right thing to do. I want every other index starting at 1 until I run out of indices. And if I were to print out these things, I could print out part sub I and see that it prints out just the operators in the order they appeared in the original. Okay? Because this is going every other index and getting me the operators. If I also print out part sub I plus 1, I'll see that's the number that follows the operator. So I have plus 2, plus 3, minus 4, and so on. So since I know the number is at part sub I plus 1, and the operator is at part sub I can use those to do my math. So I can say if that operator is a plus sign, then I want to add to the answer. Otherwise, since there are only 2 operators that are possible, it must have been a minus sign. And so I can subtract instead. And now my code grabs the first number as the initial answer, and for every operator, checks which operator it was, and either adds or subtracts the next number in turn. And when I run it, I will see that it can successfully do addition. Take 34 plus 5 plus 6 plus 7 plus 8 minus 1 and tell me correctly that that is a 59. Question?
What if the first number is a negative number?
Ah, good question. What if the first number is a negative number? Does our regular expression allow there to be negative numbers? Should we fix that? How do I fix it? How can I let my first number be negative? Sorry?
Oh, we could do a hyphen and then a question mark afterwards.
Yeah, optionally there can be a hyphen at the beginning. Great. Let's make an example that has a negative first number. Now it's all upset. What is it all upset about?
What?
Okay, notice what's happening here. Why is it not happy? So I look at this thing that's being printed out for minus 1 plus 2 plus 3. It is splitting here on the minus sign. And so it's giving me a nothing minus 1. Okay. So negative numbers actually do make this more complicated than it already was. There are ways around this. We could spend time going around this. I'm not sure if we want to. I want to see how we fix this problem. No, move on to something else. All right, we'll move on to something else. You're welcome. I'm happy to address this if you want to chat in office hours or sometime. We can make that go. Other questions? Okay. I bring up this example for a few reasons. One, to point out that split can do interesting things and you might occasionally find it useful. Also to point out that the upper bound of what you can do with regular expressions is really high. There's a lot of things regular expressions can do for you, a lot of problems they can fix. We added regular expressions to this class initially because students kept coming back after the class who only took this class, didn't take other CS classes, and said, I needed to read websites and I only sort of knew how and it was really hard using only find and splice. I'm like, oh, there's this magic thing that will make that better. Let's teach it to you. And now we find very often students, both that go into CS and that don't, will come back and mention their ability to read text using regular expressions is one of the things they actually use in whatever it is they're doing. It tends to be very useful because very often, particularly in this period of our history, there's a lot of information available online in text and you need to pull it out in some way. And so the remaining programming assignment, besides the one due tomorrow morning, will be actually going to real websites that we have not modified or made clean for you in any way and extracting information from them in a structured way. So you'll get to experience how you make this work. And many of you will find this useful as you're going along and pulling other information from other sites later in your life. This concludes what we needed to say about regular expressions. I have a few extra odds and ends we might throw in here, but any questions about any portion of our regular expression coverage before I move on to other odds and ends? Okay, if you want to wander off 7 minutes early, by all means, what I'm talking about from here on is just pure extra. So you're welcome to stick around, you're welcome to wander off, doesn't matter to me. As we've talked about irregular expressions, there's a few concepts we have not discussed. And one of them is the idea of boundaries. Let's suppose, for example, I want a regular expression that matches the word the. Maybe I realize it could appear in multiple cases, so I make this regular expression. But this regular expression will match more than just the word the. It will also match the beginning of the word there, which is probably not what I wanted it to do. Regular expressions have this extra idea in them of boundaries. There are things that we can say, I want something to be present, but I don't want to actually include it in what I am matching. So an example of the boundaries that we have is the B. \b in regular expression means I only want this to match between two letters, or between two characters, if one of them could have been part of a word, but the other one can't. So it will match between things. If I think about the end of these talks, the B will match there, and there, and there, and there. Okay, it will match between word characters and non-word characters. Even if the non-word character is punctuation instead of a space, it will still work this way. Okay? And so I can use this B, this word boundary, to make my regular expressions work a little bit nicer. This is one of the most common boundaries. Other common boundaries that are used are these. The caret, if not inside of a square bracket, the caret means the very beginning of all string. And the $sign means the very end of the whole string. And so if I put a caret or a $sign, I say this has to either be the beginning or the end of everything I've given you, in addition to the /b. These get rapidly more complicated. Let's look, for example. Where do I want to be? Here. There are many of these parenthesis question mark something 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 that regular expressions can deal with. Let's look, for example, at the parenthesis question mark less than equals. The parenthesis question mark less than equals matches if the current position in the string is preceded by a match for whatever the thing is that ends at the current position. This is called positive look-behind assertion. So here we have this strange case that a parenthesis question mark less than equals A, B, C, D, E, F will match in A, B, C, D, E, F only at D, E, F. Okay, so match the D, E, F of A, B, C, D, E, F, but not the A, B, C. Why would you ever want these? Well, they aren't very common. Okay, but there is sort of this surprisingly rapidly expanding space of things that you can do in regular expressions using these boundaries and these look ahead and look behind assertions and so on. If you ever find yourself using a lot of regular expressions, it's probably worth your while going back and learning these. Learning them now, probably more confusing than it's worth, but letting you know they exist is probably useful. Another thing that we can do is we can use what are called back references. Sometimes I want to, oh well, I can't spell backref, but that's all right. Backreg will work. Sometimes I want to know if something is repeated. So let's, for example, make a regular expression that will match if the same word appears twice in a row in some text. Okay? And actually, let's do this in Pythex. So let's write this is a test. I want to match a word. So I'm going to match a word boundary and then any number of letters. And then another word boundary. And it matches all of my words. But I only want to match it the same word twice. So I'm going to match a word, and then I want to match that same word again. I can do that by putting this in parentheses, and then say I want that again. Using the same syntax we use for sub. I can also use this in the thing I am looking for. So now I say I want a word boundary. This whole thing, I don't really need a word boundary there because I have a space there. Okay? And maybe I want that to end the word. Okay? So now I say I need a word boundary, a word, a space, the same word again, and a word boundary. And so I'll match this, and test, but not test tester, because test tester doesn't end in a word boundary. Also not this is or is a, because the first and second words are not the same. In theoretic computer science, you'll eventually learn, if you take that course, that this is technically not a regular expression. This is something more than a regular expression, but every regular expression library I've ever used uses it, including Python's. So we can write these more complicated things that will look for repeated words, that will look for things that have other things inside of them, and so on. There's a lot you can do with regular expressions. That is the time we have. I hope you will find this useful in your regular life. I will see you all a week from today.